Thanks for coming. Like I asked before, like I said before, this session is going to be in English, so I'm sorry if you expected a Dutch session. We do have some English-speaking people in the audience, so that's why I'm going to do it in English. I hope that's not a problem. If it is, you can still leave and find another session, but I hope you won't. Which one of you saw the old title session? I see 1, 2, 3, 3 people. So the old title session title was actually Containers Are Dead. Some people didn't quite agree with me, and I must say that in the session I would tell you that they are not entirely dead yet, but that in some use cases you might want to consider doing something else rather than containers. So that's what this session is going to be about. It's also going to be focused on 2 themes that are playing in my life right now. I bought a house and I'm still busy, doing a lot of stuff in the house. And on the other side, I seem to have a lot of problems with stuff breaking down. So I'm actually glad that my laptop is working today. My car isn't, it's still stuck in Serbia. That's a long story. It should be coming back somewhere in the next few weeks. So yeah, what I'm going to be talking about first is, why do I think that containers may not be your best bet? And why I think that serverless architectures or serverless stuff is the way to go. Then I'll dive into what serverless options are there. How do you go about, creating your first function? Who's done that before? 1, 2? Oh, that's not a lot of people. I expected more people to have used it already, but that's good. I'll quickly introduce Azure Functions and then dive a bit deeper into it, like how you do it properly. That's the what about section. What about, how do you test it? How do you deploy it? How do you monitor it? All that stuff, the DevOps stuff. And I'll wrap up. Quickly onto the preface. That's a brief history in time. A long time ago, I think a few years ago actually, a lot of people were still doing this, manual installations of software. Maybe you were lucky, you had some sort of guide, installation guide telling you how to do it. Maybe you even had a Wix installer or install shield. Who of you still does this, manual installations of software? Don't be afraid to show your hand. I mean, we all do it with some software, and we've all done it, right? You didn't?
Well, I've only worked for a year, so.
Okay, fair enough, fair enough. Right, how do you install your PC at home?
With installers, of course.
There you go, you've done it. We've all done it. So that evolved into people scripting stuff. Like when I started out working a couple of years ago, quite a few years now, I ended up on a project where there was a lot of manual installations of different services, which then composed a whole application, and it took a lot of time to get it rolling. I actually see someone sitting over there who's at that project now. But the first thing we did was we actually scripted that environment so that when a new team member started, they could just start a script and it would install everything for them and they could get to developing. But still quite a cumbersome process. So what you see is that a lot of companies are now moving into desired state. They describe what they want. They write, it's like a recipe, so to say. They describe what they want and magic happens, server is done, application is installed, and everything's ready to go. Still a lot of manual work. So then, I think it was about 10 years ago, people started thinking about containers, LXC on Linux, and it worked. But it was quite a tough process to, employ in your own company to do it, to actually do it, and to get the networking right, etc. So in 2014, I believe it was, Docker came out and they said, we've got a great format for containers, and put your application in it, and we'll do the rest. So everyone moved to containers and started building their own houses out of containers and their own applications out of containers, and everything was great. It worked, right? Anyone doing something with containers? Alessandro, I know you do stuff with containers. Don't be shy. So, if you've ever done something with containers, you know that it doesn't end there. You can wrap your application into a container, and then you can type docker run, and your container will run, and then at some point you're going to realize, wow, that container is still running somewhere. And I'm done. It's running, and people are hitting my application, and it works, and well, when it goes down, I'll just restart the container, and it works, except for the little state thing that people try to put into a container and then discovered, well, if I restart that container, my entire state is gone. So they pulled that out of the container, but I'll leave that aside. But then there's another thing. What about patching? I mean, your container is running, your application is running, but you still need to patch it. And where there was quite an easy process using, for instance, WSUS, I think it's Windows Update Services, for a lot of computers, that was quite easy. But now it's in the container. And you need to patch the container, but not just that specific instance of the container. No, you need to patch the image. So you need to rebuild that image constantly. You need to think about security patches. But you also need to think about the physical hosting of those containers and the orchestration and maybe auto-scaling and all the stuff that everyone wants and no one knows how to get right. At least I don't. But that is kind of what serverless delivers. It scales. It does the OS patching, the security patching, does all that stuff for you. Even better, I believe that it delivers on the promise that cloud made. I mean, cloud said, well, you'll be using someone else's computer and run it there. Serverless says, well, you'll be using our data center. Not just one computer. No, you'll be using our data center, not a VM. Forget about all that stuff. You don't need to patch it. We'll run it. Give us your code. And you're done. Sounds good, right? So we've decided to go serverless because it's just way better than containers. Not opinionated here at all. I've spent the beginning of this week hacking containers at OpenHack. Anyone been there? Besides you? No one? Thought I saw a bat. Yeah, see, there. At least one other person. OpenHack was an event sponsored by Microsoft and a few key partners here in the Netherlands. And we spent 3 days hacking in either Service Fabric or Kubernetes. Well, Kubernetes being orchestration for containers, I spent 3 days in hell getting an application to run. It's wow. Anyway, getting sidetracked. We were going serverless. And we've got a few options, actually. First out there was Amazon, using their Lambdas. And you see that, well, it's got quite a bit of traction in the market. And we've got Google, who've got their Cloud Functions, Google Cloud Functions, I think they call them. It's the original name. And we've got Microsoft using Azure Functions. That was announced about 2 years ago now at Build. It's quite a surprise. They said something about, yeah, we've got new PaaS solutions, and this is the current state of PaaS, and this is just going to wrap up about a lot of PaaS stuff. And we walked into the room, and it was like, gotcha, it's about functions. That's new, serverless. Cool, right? It was. Now that we know what serverless promises, we still don't know where to use it. I mean, what does it do for me? Well, it does quite a lot, actually. And my first actual encounter using functions was when we ended up in this situation. We've got an application, and that application runs at several tenants on their premises. So we don't really trust that. And we've got that application coupled, we couple it using Azure Service Bus. We send messages to the service bus and we pull them off. But at some point we were like, yeah, we don't really trust that one shared service bus for us and the customer. We want to separate those. We want one service bus namespace for every customer, so they have their own, and in the case that something might go wrong on their side, there will never, ever, ever be another tenant influenced by their messages. We could use filtering there, which seemed to work, but it was too easy to make a mistake. Besides, it wasn't really visible. You had to go into the programming model to get it running back then. So we decided to split them up, but then we ran into the next problem because we still wanted to get the events from the tenants back to us. And also our events, the ones our services produced, we wanted to get those to the tenant. I called a bunch of colleagues and asked them, well, is there any solution for this? Well, there is event hubs and they're expensive. They're like, yeah, I'm just looking for something that can easily copy an event from one service bus namespace and topic to another. Mustn't be too hard. And it turns out it wasn't. You can actually just get an Azure function to do the work for you. I mean, the Azure Functions, they have a trigger, which starts them up. And as soon as that trigger hits, they get some data. And then they can do something with that data and put it somewhere else, maybe onto another service bus, another namespace. So that's what we ended up doing. And that was my first actual experience with Azure Functions. Because yes, before that, I had, of course, created a function that was an HTTP trigger, so I could send my name to the function, and then I got back, hello, Peter. Yeah. So like I said, I've hit a bit of bad luck concerning my car. Any Volvo drivers out here? Yeah, I used to be as well. They say those cars are indestructible, right? They're not. I promise you, they are not. It might be me. I have been compared to Max Verstappen before, but I don't think that's true. I drive way better. I don't crash my car that often. But still, that car can be destroyed, and I did. It's still in Serbia right now. I stranded there about a week ago now, paid the toll, tried to start the car again. It started shaking, making a lot of noise, hissing. I'm like, yeah, I'm not a mechanic, but that's not good. So I was there around 8 o'clock at night, Serbia. I don't speak Serbian. So I called the ANWB. So that's basically the Dutch AAA. And they said, okay, we're going to send help, but can you just tell me where you are? I said, yeah, it says something with a V, an R, a C-I-N. Must be something like Vrchin or something. Yeah, I cannot find that. Okay, so can I just send you my GPS coordinates? No, that doesn't work. Okay. Okay, I'm currently right next to the motorway. That's the M1 E75. I'm parked at a petrol station. It's called Eco. Can you find that? No. Doesn't exist. Okay. So ironically, for this session, I was thinking about a dashboard because I had already had a bit of different breakdowns with my car, which were fixed in the Netherlands, which was good. So I thought of a solution where you're basically the driver and you have a phone client or a website where you just say help and magic happens. Someone dispatches a tow car or an ambulance if you drove over someone, or a new vehicle or anything, but just help me. I don't care how you do it, help me and do it fast. I don't want to be stuck here, I want to be on my way, and that's it. So what I thought of was that app. You post your help request to a function, the function puts a message onto a service bus somewhere, and people can actually, well, first, I've got a logger function in the middle. I'll tell you more about that later. It logs everything that goes in and out of the system. And a function that actually puts the request into some kind of data store. Now we've got the back end here, which used to be just an agent or different corporations, or I don't know, maybe a rental company, a towing company, etc., etc. They get alerted that there is something wrong with someone at these specific coordinates. So I replaced that by an agent in the Netherlands, in Belgium, and Serbia, because that's what I would have wanted in Serbia. Rather than go to the Netherlands, then get the Netherlands to inform Serbia that something's wrong, then some Serbian, very nice person by the way, call me and say, okay, I'm gonna come get you. I wanted that Serbian to be informed immediately, rather than spend 45 minutes on the phone with a Dutch person telling him where I am. That Serbian person would have probably known, ah, you're there, okay, I'll be right there. I didn't get to build this entirely because I was actually stuck there and I didn't have a lot of internet over there. But I am going to go quickly into what it actually is and looks like. I'll start at the basic function level, and then we'll build it out to actually do continuous delivery. We'll test it, etc. Not the entire application, unfortunately. Would have loved to show that. I am going to still build it and then put it on GitHub or something. You can just look at it there. But we must remember that there are a few promises that serverless makes. Spins up on demand. So only when it's used, it spins up. It isn't running in the background. Only when it's triggered. You pay for what you use, and only that. And it promises some sort of no ops, which is the patching, the security patching, etc. And then there's another one which I believe should be there. It promises security as well. Because, well, think of it like this. Your application is running. Some evil hacker is trying to get into your application. He succeeds and installs some malware. That malware is now served to your customers. But using serverless, he can install that malware, and then after he's done, the function disappears, and so does the malware. And he'll have to keep on doing that. And the annoying thing there is that he'll keep on hitting his own instance. And not yours or yours, just his own instance. Sounds easy enough, so you just have to come up with an idea. And think of something you want to build, maybe a web application. Then you insert some coffee. Works for me, but not that one. We'll use this one. And you write the code. Once you've written the code, you put it into the function, and you launch. Sounds simple, right? And it is. I'll show you. See, connection error. Great. .4G, it works. So what I made is a function app. I almost ran out of credits there. I made a function app. It was called Roadside Assistance International, and I was going to put all my functions in there. But rather than that, I put this simple one here. And this is even in the back, probably not. I'll try to zoom in a bit. Readable now in the back as well? you don't say anything, I'm going to assume it is. So this is my whole function. And what it does is I can send a request there in JSON, and it will parse the JSON, create some sort of object out of that, which happens to be dynamic, because I was lazy. You can actually create objects here, but just to show you what an easy function is, you can build it right in the portal. You just add a function, tell it what trigger it needs, build it, you're done, you return something. So this works. This actually does something. If I send a request to that endpoint, it will work. And I can actually show you that it does. And I have to zoom out a bit. My name is Peter. I've got a request. My car broke down. These coordinates, and what I want is well, call me as soon as possible. Just get someone to call me because I might have to explain something. Tow me and send me a replacement vehicle. I can run that. And, well, it's been sent. You will be contacted. Yeah, that's great. So now my message disappeared, right? It's completely gone, but it isn't. Yeah, I didn't put it on the bus actually. I put it directly into a database in this case. Because like I said, I had to create a bit of a smaller demo. I did, but it is now in a Cosmos DB. And a lot of the Azure functions, a lot of the Azure functionality is actually supported in Azure Functions. So if you want to use Cosmos DB, that's really easy. It's native. Storage tables as well. Service bus, also very easy. But what this has done, or should have done, is there's a request there in the database, and some agent in Serbia hopefully could have picked this up and helped me out. Not sure where these coordinates are, by the way, but doesn't matter. That's the whole function. There's not much more to it. I've written a simple function that's basically now an API. I could expand it to handle more requests or post messages or what have you. But that, in essence, is a function. And the test looked great, right? I mean, I can just go into the portal, send some data, and I can see that it works. Is that how you test your software? I'm glad you said that, sir. It isn't how I test mine either. So what you would probably want is some sort of at least unit testing, right? If you don't agree, just speak up. I will hunt you down after the session. So yeah, you must do something with testing, you must do something about deployment, because you're probably not going to go into the portal every single time and upload your code and then go to the test tab and enter some data and get it wrong and try again and again and again until it works. And you probably want to monitor your function once it's running, and you want to version it, maybe get different versions running or replace your function with a newer version. And you also want to do some sort of tracking, because imagine you build a very large system with a lot of events and messages going over those service bus. And you probably want to be able to see what happened to a message and how that process is going. Where is it stuck? Is it stuck in Serbia? Then I'm going to send an alert to someone else to escalate it to their manager or something and get it going again, because your customer is what matters. Deployment. Who here uses TFS? A lot of. VSTS maybe? Yay. That's good. But you can use VSTS, or TFS. I mean, it's just code, and you can check it in, and then you can use a build, actually, that creates a binary, and then publish it using release management to Azure. That's easy enough. The testing, however, you've got a few options. One of them is using some sort of integration testing. Any of you people know SOA tests or SOAP UI? A lot of those older tools. You could do something like that. I mean, you can run these functions locally. There's a runtime which allows you to run it on your own server, which is kind of weird because they said it's a serverless proposition, and then you can run it on your own server. I actually had a discussion about this with Marcel de Vries about this. I said, well, you know, it's serverless. Yeah, but you can run it on your own server. Like, yeah, but it's serverless. No, but it's no. It is cool because it allows you to test it on your local machine or in your build. Another option is, you've seen the function just now, which was just a bit of code, but you can actually use a class library. Include that class library and test that class library like you would just about any code. You can just create a class library, unit test project, test the class library, and a function will call the library. That makes, well, up for just about most of the things that can go wrong. Your logic is in that library, not in your function. Your function just does the plumbing. The monitoring, they offer you a version in the portal, which gives you basic information about how many times has it run. Maybe it built some logging statements into your function. Some of you may have noticed the trace writer that was in there. You can see that as well, but it's not great. Another option is, well, do it manually. Create something to monitor your function. Just call it every now and then and see if you get back what you expect. The third option is integration with App Insights, which they launched somewhere a few months ago, which actually works and gives you a bit more information, actually real-time information about how many times, near real-time information about how many times it's been called, how long it took to process, etc. Now the versioning part, I have to admit that's a bit harder because your function right now only supports deployment slots like you use in web apps in preview. I mean, you can test it like in your pre-production, your test or whatever phase. You can test it in production, but then once you swap it, well, it's a new version. So what we use is Azure API management. We've got an endpoint in API management. You just call it. And we can use API management to actually arrange the different calls and different requests and spread them or point them in the right direction. And we've got the tracking part. How do I keep track of my process? Well, use a correlation ID. It's that simple. If you then use the same functionality as what I put into the architecture slide somewhere way back there, you see that logger function will actually log every message. If I have a correlation ID, I can easily see what happened in a process. I can write my own custom views, or I can use maybe Azure Machine Learning to get some more info on those processes and see if one may slow down or if someone has actually done something really weird, like anomaly detection. You can do it all. But yeah, I'm just, I see that I mixed up one slide here. I'm just going to show you how most of these things can be done quite easily. So what we saw was a, yeah, you see the same as I do. What you saw just now was a function which I created in the portal. And I could edit it in the portal and test it in the portal, which was great, but not quite what I wanted. So what I did was I created a different function, the dispatcher, in Visual Studio. If you use Visual Studio 2017 and you enable the Azure workload, you get this for free. You just say create a new Azure function, add a and that's it. So this is pretty similar to what I did before. The only difference is that now I'm using a DocumentDB repository to store all my data. And I wanted to use dependency injection, but that doesn't quite work as well in static classes. Mind you, these things are static. It's not great, but it works. If you want to improve the code, feel free. And I've got some dispatcher logic that actually does my work. So this is my repository with the credentials. I will delete this after this session, but it's on video now. And I've got my logic, which is also very simple. All it does is, well, you get some JSON, parse the JSON, and store it. Yes? Bigger? I can, definitely. I hope. Oh. The virtues of working on a Mac. Yes? Better? Also in the back? Great. So it's just really simple code. I've got a repository which I need, and here I did extract my interface so I can actually test it. I get my JSON, which is my HTTP request, which comes in, and I save it. And I do actually parse it to a model here. Now, like I said, I mean, if you do this, if you create a class library and you reference it from here, there's my logic, then all I have to do is create another project, a unit test project, and test it. Now I'm going to scroll through this really fast because I thought my colleague Simon would give his session on mutation testing after this one. And then he could have told, well, I would have sent you there and said, well, this unit test does test something, but it's not really that great. It will succeed, but it won't actually test anything, and do mutation testing if you want to get your unit test right. So yeah, do it anyway. Look at Striker. But I've got my code, I've got my tests, and it all works. And I have actually committed this to a repo for which I will maybe need to switch back. I don't. This is my code. It's actually the same code. And I've got a build, which will build mainly the class library and create the function and point it at the class library and then create a zip file. That looks something like this. Mind you, if you start using functions and you want to get doing this afternoon, choose the .NET Core build, because other builds actually don't support the functions yet for builds. But this will do your usual stuff. It will use the newest NuGet. That's awesome. It will restore your dependencies, build your solution with a lot of MS-build magic happening there, which creates a package, a web deploy package. It will test my assemblies, publish it, and, well, the usual stuff you do in a build. So my build did actually succeed. I'm glad to see that. And I do actually see my test result here, which is 100% green, which is easy if you have just one test, which doesn't really test anything. Now we have another thing, that's actually the deployment. So I created a release definition which, well, deploys it. It's tied into the build that I created. It's on a continuous trigger, and it does just one thing. It deploys my Azure App Service, because beneath it all, that's what the functions run on. And you've got a pay-as-you-go plan, so that you just pay for your usage, but it is still app services. That's my release. So I've got my releases covered, my deployment covered. I've got, well, just about everything covered, I think. I mean, if we look at this, I've got my deployment, I've got my testing. The versioning, I will not show you now, but you can easily do that using Azure API Management. And I've got a bit of tracking using a request ID in my case. Anyone want to see if this works on Friday the 13th? Using my luck. Do you want to see the fully automated version, or do you want me to see it running locally, debugging, sending it a request? I'll quickly do that anyway, because I might as well do it in the time that I'm saying this. So it's running now, locally on my machine. This is that Azure runtime. And I've got an endpoint which I can call. And I've got Postman open with a request, and my car broke down again and again and again. And that is actually the case. I will send it, and that's it. Now, if you don't believe me, it is actually there, I hope. There it is. My car broke down again and again and again and again. Call an ambulance, because I hit someone. That's it running locally. Now, what I can also easily do is, well, let me just, thanks for your request. We won't actually do anything here. Changed a response message. I commit and push. And what should happen now? Oh, once it has pushed. What should happen now is that it will actually start a build, then start a deployment. Oh, it is running. And it actually takes a while. So if I can, in the meantime, quickly hit the old endpoint. I hope I didn't change that. I didn't. See? This is the old message. It's hard to read, but I'm going to try and zoom in there. Whoa. There. That's the old message, the old response message we had. Still there. Meanwhile, my build is still building in the back, doing a NuGet restore. One of the things I liked about .NET, and okay, I still like .NET, don't get me wrong, but one of the things I liked was that you just had it. You didn't have to restore a lot of stuff, not like Java, get Maven to pull in the entire world before you can actually build your software. It was just there, not anymore in .NET Core, but it does work very much faster, so I'll forgive Microsoft for doing that. It is now actually only building my solution, then the testing should be done really quickly, and what it will do after that is trigger the release. Release will be deployed, and once I hit that endpoint again, I will get a different response message, and it will still work exactly the same as before. Question there?
While we're waiting, can you give some examples of disadvantages of using Azure Functions?
Oh yes, they're coming. Yeah, yeah. No, there are definitely some disadvantages. I will get to them really quickly. The reason I kept my demo short is because you only have 45 minutes. This is deploying in progress. Also takes a while. You'll just have to trust me that it works. And if it doesn't, feel free to come visit me at this the InfoSport stand later on. You have a question or? To, sorry, what? To how does it map to an API endpoint? Well, the function can be an API endpoint if it uses an HTTP trigger. So you can call it directly as like you would call an API endpoint. And that's how you can create very large applications. I have to quickly continue, so I'm going to ask you to hold your questions for after the session, or come visit me at the InfoSport stand where I will be after this session. So if after this you think that you're going to start right now and get going, well, there are some pitfalls, there are some disadvantages. One of the main disadvantages, I think, is that live debugging doesn't really work yet. They are promising to come with a solution that you can actually attach your local Visual Studio to your function in the cloud and debug, but not there yet. And there's also another offering which is called Azure Logic Apps, which allows you to create this even easier. You don't have to write any code, which is really awesome for business users. You can just drag in some, maybe you've seen the demos about AI and sentiments on Twitter and that kind of stuff. That's actually done in an Azure Logic app. You've got an interface, you drag in different components and you're done. Really awesome, but they're also way more expensive and actually cost us, I think it was about $2,000 within a 5-minute time span because, well, we screwed up and created an endless loop. And that's why you test it. So we also have an issue where host keys, which the function needs to run, actually disappears. Not quite sure where it comes from, but you can just regenerate them in the portal and it will work again, but yeah, not so great. Although I must say that in preparing these demos, I haven't had that again. So maybe they've already fixed that. Then next to that, you still have your responsibilities for monitoring and testing and learning from what goes wrong and putting that back in. Now, if you look at disadvantages from functions as opposed to containers, I don't believe there are any big disadvantages, more that containers might actually make sense and do actually make sense for a lift and shift of applications. If you have an existing application, it's easier to wrap it in a container and put it somewhere than it is to recreate it as a function, because the purpose of these functions is to be very small and to be fast.
Also moving between vendors.
Yeah, that's also one, moving between vendors. I mean, in the end, it all boils down to code, and it would require minimal adjustments if you use proper abstractions, but yes, vendor lock-in is definitely one of the things. Let me see, we already had the demo, and then there is one thing I still want to tell you. There is still ops involved. I mean, no ops in the whole serverless promise story means you don't have to patch your servers. You don't have to care about your servers. You don't actually have any servers. And you just pay for what you use, but you still have to monitor, you still have to test, you still have to learn, you still have to do all the other stuff. And if it breaks down, you still have to fix it. And that's pretty much my story. I mean, functions, I'm gonna get functions are really awesome. So are logic apps. So they've both got a place. Logic apps maybe for low volume stuff, functions for the high volume stuff, and that which also requires APIs and interaction with users. Just give it a try and see how it does actually also force you to think differently about your applications, to decouple them, to use a service bus or messages or events, and to create true microservices, like nano services or something. I'm just going to take that one question.
You mentioned you don't have to do the old Fetch-Rule anymore.
Mm-hmm.
Do you have any control about what kind of platform you're running on? I mean,
It really depends. If you use the pay-as-you-go model, then you don't really have a lot of control. If you use your own environment, then yes, that's basically an app service plan, so you can create an app service plan using a specific tier. So yeah, you do have some control, but not a lot.
Then you still have services.
Yeah, then you do have services, yeah. So feel free to reach out. I'm on Twitter at Toonen, LinkedIn. That's not in Serbia, that's in San Francisco, I think. And if you have any further questions, I'll be at the info support stand down in the hall, which is due to logistic stuff. I'm already over time, and thank you very much for coming.